Ed Parsons, please. The floor is yours. But first, a question. I read on your homepage that you're a person that based wherever you can plug in your laptop. Well, a few years ago, you had to look for places like that. Is it the other way around now? You have to look for places where you cannot plug it in your computer?
I think we're almost at that point. Certainly, when you want to rest, you want to find those places where your cell phone's not going to work, you're not going to get email, and perhaps we can help you find those places in the future.
That would be an innovation looking for.
Absolutely.
Well, okay.
There's always a business opportunity.
Okay, thank you. The floor is yours.
Thank you. Well, good morning, everyone, and thank you for taking the time to come and listen to me speaking to you in English. I promise you, your English is far better than my Swedish, so it's much better we work that way. I'm going to spend the next half an hour talking about some changes that we see at Google in the world of geospatial technology in terms of GIS, buildings, and so on and so forth. Actually, the labels today don't mean as much as they used to do. We used to spend all our time arguing whether we were cartographers or GIS people. Actually, much of what we do now is mainstream. The labels are less important. But the topic I want to talk about is perhaps an idea of changing the scale, changing the focus at which we work. To start off, I have to talk about what we do at Google in general. And Google's mission, everything that we do is built around this idea that the information is the resource of today's age. You know, we make economic benefit by getting access to information, getting information into the hands of the people that need to use it, and obviously allowing people to create more information. That's the thing that's really changed, I suppose, over the last few decades, is we are all creators of information as we live our day-to-day lives. Google's mission is to connect people to the information that's important to them at a particular point in time in a particular place in space, so they have the information that's useful and relevant to them. Google started out very simply with that search engine, and obviously that's where most people think about Google in terms of search. But search is only part of making that information available to people. Very early on, we worked out that to make search work well, we had to recognize where people were and what they were searching for was. Because often when you're searching for something online, you're actually searching for a place or a location of a business or an activity. So we had to build maps to make search work better. And just to kind of prove that building maps is a never-ending process, that's what Google Maps started out like. You can see we had a work in progress there. But an important part to this is, and I guess this is a little bit about how the web works, that was Google Maps. We released Google Maps, which looked like that. It only worked for the United States, Canada, and the UK. And people started using it and allowed us then to build more and more functionality. And that's, I guess, one of the ways that the web is different, in that you have a very minimal product to start with, and you build more and more functionality as your users tell you what's important. Maps are really popular today because we carry them around with us. We have maps in our pockets that can tell us whereabouts we are in the world, and they can tell us about the world around us. And we take that for granted. We take that as a piece of technology that just works. But I want us to sort of stop and think a little bit about this. What does this capability mean? And perhaps behind the scenes, when we work on Google Maps, one of the things that we're thinking about is what does what we do have as an impact on individuals? And perhaps, if we're doing our job properly, you will never feel lost again. And I want to think about what that means. Remember the last time you were lost. Perhaps you were a child, or you were late for a meeting and you were desperate to try and find out where you were. Think about how that felt. It's not pleasant. It's not something that we like. But if we're doing our jobs properly, you shouldn't feel lost. You should be able to, as is the case here, find yourself on a street in Nairobi and be able to get back to your hotel without worrying, without thinking too much about it. And we can do that pretty much now anywhere in the world. So we'll never feel lost again, unless we want to. unless we want to go off and find somewhere where we can't get an internet connection and be quiet and make that conscious decision. But we shouldn't feel lost. We shouldn't have that negative sense again. And obviously what we do is more than just creating a map. In the early days, yes, that's what we were after. But now the map itself is much more of a living interface into other pieces of information. So here we are in the conference center. I can pull up the address. I can pull up telephone numbers. I can get directions to the conference center from whereabouts I might be, anywhere else in Sweden. I can read reviews of what other people have mentioned about when they visited this particular location. So it's more than just a map. There's connections to all those other types of information. And I can connect to other services at the same time. So if I was coming here and I wanted to, say, book a hotel, I should be able to search nearby for hotels and just with 1 or 2 clicks be able to book those hotels at the same time. So the map is something I look at, but it's also something I can interact with and get access to other services. Another big change, I suppose, is the use of imagery. We have high-resolution imagery of most of the world now. Certainly most urban areas, we have it at sort of 30 centimeter, 15 centimeter resolution. Not as high as you could possibly get aerial photography, but high enough that it gives us a sense of what those places look like. And from the same method of capturing this largely aerial photography rather than satellite imagery, as I'm sure most of you are aware, we can also build up 3-dimensional models. This is Malmö. And this is built from just aerial photography, just by flying a grid pattern over the city, doing photogrammetry on quite sophisticated computers now. So the functionality, the sophistication has moved from the cameras now to the processing of the data and allows us to build quite realistic, I would argue, views of cities. But I think the thing that we're perhaps most proud of, the thing that we did really differently, was to introduce Street View. Street View for us is that last level of zoom. Take you down to as if you're standing on the street corner, what does that look like? Allows you to get a sense of the building entrance that you're going to be looking for when you get to your destination. And obviously that works if you're driving along in a vehicle somewhere in the center of Stockholm. But if you're out in the outskirts wanting to get somewhere quieter, the challenges of capturing the imagery are more telling. But it shouldn't stop us. We use whatever motive power is available to go and collect Street View imagery. We now have Street View imagery of pretty much every continent. Well over 50 countries are covered by Street View imagery now. It allows you to get that sense of what somewhere feels like. The latest country to capture was Nepal. And you can now walk up to the base camp of Mount Everest in Street View and get a sense of how that place is different to where you might live. This is great in education, in schools, making geography relevant to people again. Saying why, how your life growing up in the suburbs of Stockholm would be very different to growing up in a village in Nepal. And it is because of that sense of place, I think, we find this important. And what I mean by sense of place is a feeling that one place is different to another. I'll give you a very quick demonstration of that. Here's Street View imagery of Paris and Washington. And I think you can, just by looking at the images, even if you can't read the text, you'd know which was Paris and which was Washington. Just by looking at the street, by the architecture, by what you look at, that sense of place, that feeling that one place is different to another. And you can see it just from those photographs. That shows you how powerful as qualitative information that is. Something that perhaps as an industry we've kind of largely ignored. We're very much into quantitative, measuring things precisely, working out the size of a cadastral parcel to the nearest few millimeters. But actually most of us in our real worlds, and most of the rest of the people outside of this room, think much more qualitatively. They think about, how does this place feel? What's the emotive impact? And that type of information is much better presented as photographs than traditional cartography. The other way maps are a part of our day-to-day lives is we use them to navigate. We now have on our mobile phones the equivalent of what was a traditional satellite navigation system, GPS. We now have lane guidance in about 25 countries, Sweden included, so it makes you be in the right lane when you're driving around. And as a visitor to a new country, knowing which lane you should be in is really important. That information is also real time. So we have, based upon other users of Google Maps as they're driving in their cars, we can have a real-time road status network here telling you how long it's going to take to drive, say, from Malmö to Stockholm. Let me just show you how that works, because not only are we getting that feed of how quickly you're driving on a particular road, the average speed, we can also identify when incidents happen, when the car breaks down or there's roadworks. Let me just show you a quick video of that. So here I am wanting to look at a particular route, in this case in the Silicon Valley, but you can see I can find out when an incident happens. Now this data is either coming from local organizations, so local municipalities, or it could be crowdsourced. It could be people driving, seeing something, a car broken down or there being roadworks, and just tapping something on their phone very quickly, and that information is then recorded and shared to the other users. And this is increasingly a pattern that we see, in that users of applications are also then contributing information to other users of applications, and you get this virtuous circle. The information gets better the more people that are using the application. Where this becomes, I think, most exciting is what I like to call location superpower, where because we have this idea of the world around us, and we know ourselves as individuals, the things that are important to us at any particular point in time, we can kind of connect them. And what I mean by that is the maps that we all look at need to be relevant to us as individuals. Now, this is an optional thing we have with Google Maps. You can choose to log in to Google Maps. And when you do that, information about you, i.e. the places that you might visit and your home location and your work location, suddenly become available to Google Maps to use. This is an option. You don't have to do this. But if you do, your maps become much more personalized. So this is my map of the center of Stockholm. And you can see, where is it? Just about there in the middle. You can see the Sheraton Stockholm Hotel with dates underneath it. And that's telling me that that's the dates that I'm going to be staying at that particular hotel. So that's appearing on Google Maps, on my version of Google Maps. So now I have my own personalized Google Maps, and if you log in, you all will have your own personalized version. So it knows that I'm staying at that hotel. And then if I come back in 2 years' time, that hotel will be highlighted because that was a hotel I've stayed at in the past. So I can't quite remember where I was staying, or Google Maps has remembered. So the map has become personalized to me as an individual. Take that one step further. Your map knows where you are because you're carrying your mobile phone around with you. It's got a connection into your calendar, so it knows what you should be doing next. And it's got an idea of the traffic conditions and transport around you. If you connect all of those elements together, your location, what you're going to be doing for the rest of the day, and the transport around you, you can make these sorts of connections. This is a real screenshot from my phone from a couple of weeks ago, where my phone buzzed and it told me, okay, I know that you're flying from London Heathrow to San Francisco this afternoon. It's now time to leave home because the public transport route that you've chosen, and the one that you use most frequently, this is how long it's going to take you to get there. Based on the real-time traffic conditions, it's time to leave. So here the phone is kind of proactively helping you say, oh, something's happened. And if, say, for example, there was a traffic jam, or perhaps the buses are on strike, it would give me different information. It would tell me to do things differently because it had those connections to all those various pieces of information about me. Another element of that real time, if you go back to that navigation example, if when I'm driving, there's information about the route and there's a quicker route perhaps because the traffic conditions have changed, I'll get that information presented to me. It says, there's a faster route now. Do you want to go on that different route? And off you go. So maps have become something that's very dynamic, that happens in real time. It's no longer the case that once a year we go and buy a road atlas. Now that road atlas is changing in almost real time. And the other big change is that the maps that we look at, that we produce, find ourselves into lots of other applications. They're part of an ecosystem. And I just want to show you a very quick video about how the technology that we've built at Google for Google Maps is then also used by other organizations to build their own apps, and that's through the use of the Google Maps API. So I'm just going to show you a very short video about that.
The Google Maps API is more than just a map. To prove that, we set out to visit 6 developers on 5 continents in just 8 days. We went to their offices, workspaces, favorite pubs, and even their living rooms to show you who they are, what drives them, and why they trust the Google Maps API to build the next generation of the web.
Welcome to São Paulo. My name is André.
And my name is Rodrigo. We founded the Pungo.
G'day, I'm Ian Cumming. I'm from Site4 Labs and I'm the founder of getflight.com.au.
Guten Tag, my name is Michael Pletziger from UBI Labs in Hamburg, Germany.
My name is Vachala and I'm from Computerology and develop application using Google Maps API.
Hi, Barizeno. My name is Bernadette Deke. I develop Google Maps API for management tests.
What we found was a vibrant community of developers creating amazing applications.
We're a technology startup based in São Paulo, Brazil, and focus on the real estate market.
GetFlight lets people find and search for cheap airfares in Australia and view it on a map.
Computerology has used Google Maps API to help people find ATM and save people from flood in Thailand.
You can see our developers working on Google Maps-based applications. We work for clients such as BMW, Deutsche Telekom, Swiss Post, but also for non-profit organizations.
Icanto is a social local guide. We are a place where people can search for places that they want, write about it, find recommendations.
You're invited to come along with us and meet these innovative developers on their home turf, as they show us how a map can be more than just a map.
If you've got the time, certainly go and visit that website. But what's interesting about those developers is very few of them are geospatial experts. They've not necessarily had perhaps the same training that many of you in the room will have had. But what's interesting is that they're part of this ecosystem where if we make this information available using web technologies and try to simplify much of the underlying complexity that's there, it suddenly allows this huge mass of different individuals, different communities, different business opportunities to build upon what we've started to do. Many of those people, they may never come and talk to us directly. They go off and they build their applications anyway. That's been a huge change, and that makes this next statement more true than ever. Maps are now more widely used than at any other point in our history because they're much more accessible. They're something we can use on our phone. They're accessible to us in lots of different applications that are built by different communities who may never have used maps in the past. But there's this huge growing community of users. We have this test internally at Google to say, are we building something that's really useful? And the analogy we use is, are we building something like a toothbrush? Is it something that people will come back and they will use daily as part of their day-to-day lives? That's the level of interaction. That's the level of benefit that we want to see. Something you're going to come back and you're going to use again and again and again. It becomes part of your daily life. Okay, now I mentioned this idea of changing scale. I think we're at a kind of an inflection point, a tipping point in our industry, where we're suddenly starting to say, well, actually we got the outside of the world really well mapped. We know what we're doing there. The next challenge we have is in the West, we spend 70% of our lives inside buildings. And the geospatial technology that we've created up until now stops as soon as we get inside the building. We don't have maps really and plans of indoors widely available. And the location determination technology that we've traditionally used in terms of GPS, GNSS systems stops working as soon as we go indoors. So there's a lot of focus now in the industry and at Google about how do we solve that problem? How do we map indoors? What we want to be able to do is to be able to locate you in a gallery somewhere to say whereabouts you are and what you're looking at, what's around you. What's the world around you when you're indoors? Now, the technology that we're looking at using for this is perhaps not the technology you might expect. This is one of the famous Google self-driving cars. And if you only ever pick up one new term from today, it's SLAM, simultaneous localization and mapping. SLAM is how the Google self-driving car works. SLAM is the process of taking on the scanning laser, the Velodyne system on the roof, taking the output of that and turning it into a real-time map that you can use. So it's as if you're creating the map at the same time as you're using it. Now, what we've done is taken that technology of kind of laser mapping and shrunk it down that will fit on a backpack, and we call that the Cartographer backpack. And it is basically off-the-shelf components. There's a couple of laser rangefinders, an inertial measurement unit, so something that senses movement, and then a logging computer, and it's all controlled by an Android app that you carry around with you. This basically allows you to walk around a building, and I'll show you a quick video while I'm describing it. Basically allows you to walk around a building carrying this backpack, which is scanning using that laser and the inertial measurement unit, so it knows your movements. And as you walk around, in this case, the Aviation Museum in Germany, it's building up that map of the world around you, that floor plan. We then obviously have to do some post-processing of that data to recognize different levels and the underlying sort of topology of the internal building structure. But it might be a way that we can very quickly build internal maps of places that otherwise we'd struggle to get access to. It then allows us to have these sorts of applications where we can go down, in this case, this is a hotel in San Francisco, and we can work out, okay, whereabouts are we at any particular level, work out where the restaurants are, and solving that problem, particularly of big American hotels, is to identify whereabouts your room is in this big, huge building. You know, which direction do I need to turn out of the elevator to get to the hotel room? So solving indoor mapping, indoor navigation is certainly something that we and many other technology companies are looking at. But there's another element to the indoors, to this kind of change of scale. And that's much more about, I think, your location relative to the things around you. Let me give you an example of what I mean. This is my home in southwest London. It's kind of in the middle of the street there. And just before I left to come to the conference, I counted the number of Wi-Fi devices I have at home. And this, I keep updating this as I do this presentation. At last count, I have 90 devices connected to my Wi-Fi at home. Now, that might be extreme. I appreciate that. It might be a little bit extreme. Because I have speakers, lights, thermostat, smoke detectors, small laptops, and I find laptops in drawers that are connected to the Wi-Fi, loads of stuff. But what's interesting about all of these devices is that we've reached a point now where many of them are talking to each other. They're intelligent, they're building up a network. There are two sets of devices I want to talk about. This is my Nest thermostat and smoke detectors. Both of them are connected to my Wi-Fi. They build their own internal network, and each of them have proximity sensors, so they can sense if people are around them, they're nearby to them. So I have my thermostat in my corridor, my hall, and I have smoke detectors on every floor. So those devices can sense when I've left the building and when there's no one else at home. And what they do then is they automatically turn the heating down. So it saves energy. And in about probably 15 to 20% of my bills have been reduced by having these devices. Now, over a period of time, the devices also work out, when I get home and I switch the heating up, how long it takes to warm the house. And it turns out that my house, even though I've invested lots in double glazing and all the rest, takes about 30 minutes to get from 15 degrees to about 21 degrees. So that 6-degree increase, which is normally what I have, takes about 30 minutes. Those two devices, because they're on the Wi-Fi network, they're also connected to my tablet or my mobile phone, which knows where it is. So, connect the two together. When I and my phone get about half an hour away from home, the heating automatically switches itself on and starts warming up the house. So when I get home, it's nice and warm. That's intelligent use of these devices They're working together, but they're also sensing where I am and interacting in a particular way. And I think this is where this kind of change of scale works. In the past, we've sort of thought about geospatial technology with a coordinate system that is largely arbitrary. You know, we have the prime meridian that runs through Greenwich, and we have the equator, and then we measure latitude and longitude from those two from that point, from that origin. In the future, many of the applications that we think in terms of geospatial will have a coordinate system that's based on you, on your location or where your mobile device is. And actually, the coordinate system is going to be relative to where you are. So you carry around your own sort of personal coordinate system, and you start to see applications that are making use of this idea of proximity and locality at a much smaller scale, increasingly appearing. Here are two. There's one here on an Android phone that basically says, okay, I can sense the security state of where you are based upon the location of the phone, in this case the Android device, and maybe another Bluetooth device you're carrying, say your watch. So if I know that your watch and the phone are close to each other, I will say, I won't need to lock the phone because I know that you're together. Or it could be, I won't lock your phone if your phone's near your laptop, or it's near the Bluetooth speaker in your car. I know that those two being together, you're probably sitting in your car, you won't need that same security feature. The thing that I always end up losing are my keys, and I have an app there that was one of these Kickstarter projects called Tile, and Tile is a little Bluetooth tag that you attach to your keys, and it forms a little micro network, and it will allow you to basically find your keys wherever you might lose them. You can go to your app, says where are the keys, it records roughly the location, and once you get to that location, you press a button, and the keys start bleeping, and you find them. So not only will you never be lost, hopefully your keys will never be lost. Now, part of the way these things work, and why this idea, I guess, of the Internet of Things is taking a while to develop, is each of these apps are specific. They're built to their own particular requirement. You end up with these different tags, Bluetooth LE sensors that you plug into things. One of the things that we've been working on, some of the engineers at Google have been working on, is there a way of making this open in the same way that the web is open? And the idea we've come up with is something called the physical web. This is a physical web tag. So it's a Bluetooth LE sensor. But all it does is present a web address, just a URL, to anyone that comes up with a device. And what that URL tells you to do is, okay, once you come up to this device, go to this website, and then whatever else happens, happens at that website. It tries to bring you that level of interoperability. So at the moment, this little tag here is connecting just to my web page, to my blog. So if you came up with a phone with Bluetooth LE, held it within about a meter of my device and looked, it would then say, okay, this is the website you want to go to. Now imagine having these tags in ticket machines, in vending machines, in all those things that you kind of interact with in the real world. They become just features on the web. They become objects that you can interact with in an open fashion. You don't have to have the particular app downloaded. You just use your web browser. And I think that's potentially the way that this could all work in the future, of having this technology rapidly available to us. Right, I want to conclude now just thinking about some final thoughts. You know, I've been in this industry well over 20 years. And one of the things I think that we've struggled with in the past is that we've always, in effect, built our technology on top of what was going on the rest of the web. So the geospatial industry, maps, cartography, we were kind of surfing on top of the other developments of the web. So we took the web and we said, okay, let's have this little bit of the web that's going to do mapping, and that's what we'll do. And the underlying technology changed, but we were happily surfing along doing what we did. And that was okay, and that brought us to a particular size. Where our future lies is, I think, in bringing what we do to the rest of the web. Not doing things specially, but doing things in the same way the rest of the web works. Can we create, in effect, the geospatial pill that everybody takes, that brings a little bit of geospatial technology into all those various activities that we do. So your location is part of every interaction that you do. It connects us at that level of every web page. Imagine if every web page was talking about a specific location, and every location had a web page associated with it. You know, the huge development, the economic change that the web has brought us, if we can make that connection between the virtual and then the physical, I think there's a huge opportunity for us. Just means that we need to think a little bit differently, to change our focus, I guess, to be part of what goes on the rest of the web. Thank you very much for listening.
Yeah, it's perfect. It's perfect.
Right,
but just one question. You said never lost. On the other hand, that's something, you know, makes you stronger if you've been really lost in a forest. So that would be an application to look for,
Absolutely.
where you can get lost, and we'll find you later on when you have your crisis.
Find a quiet place that I can go and be lost in. But as soon as I've finished being lost, I can find myself again.
Thank you very much. That's
My
very
pleasure.
promising. Thank you.